This is an example of an incoming service to an idle UE. There is a person that wants to talk to our end user, an incoming voice over IP call. An IP packet sent from the outside world carrying a SIP invite message will arrive into the mobile network in the PDN gateway. The PDN gateway is the only true router in the mobile network, as we learned in the chapter User Plane with Service Establishment. From the PDN gateway's point of view, the attached UEs are always IP logged on and IP connected. The PDN gateway doesn't care if the radio bearer and the S1 bearer are released or established. It has assigned an IP address to a UE, and now there is an incoming IP packet to this IP address. So, PDN gateway passes it on to the serving gateway. The PDN gateway is not responsible for holding any information of the current status in the access part of the network. The PDN gateway knows that there is an incoming IP packet to the UE, and it is the MME that knows in which tracking area the UE is at the moment. But there is no signaling interface between the PDN gateway and the MME. This is the reason why the S5/S8 bearer between the serving gateway and PDN gateway, named default bearer, is kept. But the serving gateway will discover that there is no S1 bearer established for this UE, since it is idle. The serving gateway will then signal to the MME with a GTPC message that there is downlink data to the UE. Since the UE is idle, the network needs to page it in the tracking area. It is the EMM sublayer of NOS that holds this type of information. But the NOS layer is used for communication between the UE and MME respectively. Paging is a message sent out by all the eNode Bs in the tracking area. Therefore, the MME needs to instruct the eNode Bs to page the UE. A protocol for communication between an MME and an eNode B is required, the lower layer S1AP. When the paging instruction has been received by the eNode Bs within the tracking area, they will use their top protocol on the air interface to page the UE RRC. Here, a closer look on paging. Mobiles that are paged are of course idle. Idle mobile phones don't have a radio connection nor a cell RNTI, but what they have though is a paging RNTI. The paging RNTI is a predefined identity with the value FFFE. The paging RNTI is used as input in the CRC of physical downlink control channel to inform the UEs in the paging group that a paging message is about to be scheduled on the radio resource. The paging message shall be read by all mobiles belonging to the same paging group. In order to save battery, the UE listens for paging following paging DRX. The DRX pattern is based on MC together with other parameters provided in system information, and points out for which subframes the UE must wake up to check PDCCH with DCI addressed with paging RNTI. The paging is an RRC message sent on the logical channel paging control channel, the transport channel paging channel, and the physical channel physical downlink shared channel. Learn more about paging in the Spec Tool Chapter RRC and Physical 36.213. The paging message is broadcasted by all the eNode Bs in the tracking area. But the paged UE now continues with the one it hears the strongest. What follows now is the same as in Chapter Traffic Case RRC Connection and Attach. The UE needs to know where it is allowed to send a random access to start the procedure of establishing a radio resource. This is information to be found in SIB 2. Please note that it is always 100% of the cases the UE that initiates the establishment of a radio connection by sending random access. The closest the network gets is that it can broadcast a paging message to the mobile, but it is the mobile that answers to the paging to one of the eNode Bs with random access. Random access response, as in chapter traffic case RRC connection and attach. RRC connection request, as in chapter traffic case RRC connection and attach. As in chapter traffic case RRC connection and attach. In this traffic case, the RRC connection setup complete message will carry the NOS EMM message service request. This message is an empty message sent from the UE to the MME to indicate that the UE wants to go from EMM idle to EMM connected state. Let's compare. The empty random access message is used on the MAC level to initiate a radio connection. The service request is also an empty message used on the NOS level to initiate a NOS signaling connection. To the service request message, there is no response message from the MME. The UE will understand that the request was received successfully by the MME if it receives an RRC connection reconfiguration message establishing the lower layers. The core network is able to read the QoS parameters within a SIP invite message. During the signaling on the air interface, the PDN gateway will turn to the policy and charging rules function to get the QoS profile of this session approved and negotiated. The PCRF is a part of the IMS platform. The user location is sent to the PCRF as an input to the charging decision. If you want to learn more about Service Data Flow and Traffic Flow template, please visit the Spec Tool chapter NOS. If the default bearer has a QoS profile, which is good enough for this session, it will be used. But if not, additional dedicated bearers will be established. A dedicated bearer is only up and running as long as the lifetime of the session. When the service is released, the dedicated bearers will also be released. In this example, dedicated bearers will be activated. The PDN gateway will send a create bearer request to the serving gateway carrying configuration information of the dedicated bearer to be established as well as charging information. This is passed on to the MME. The MME will continue the signaling with an S1AP message to the eNode B. When RRC connection and attach was the traffic case, this message contained NOS, attach, accept. But in this traffic case, as stated earlier, there is no NOS response on a service request. But nevertheless, there will be an Activate Dedicated EPS Bearer Context request. To the UE, an RRC connection reconfiguration message is sent. This message includes the configuration of a signaling radio bearer as well as a data radio bearer. Here, it is Signaling Radio Bureau 2 that is configured. On the signaling radio bearer, the UE will send the Activate Dedicated EPS Bearer Context accept. The data radio bearer is to be used by the service. On the NOS level, the UE will be informed about to which IP address this dedicated bearer should be linked. The UE will also be given the TFT. The TFT determines the mapping of uplink packets to the correct radio bearer, and negotiated QoS level of the service. As always, an empty RRC connection reconfiguration complete, and then the signaling of the configuration of the S1 and S5/S8 bearer in the core network. The user plane is now established. As mentioned earlier, dedicated bearers are set up when the QoS level of the default bearer is not enough. The dedicated bearers will remain activated as long as the lifetime of the service. The default bearer on S5/S8 will, on the other hand, be activated as long as the UE is attached and has an IP address allocated from the PDN gateway. Please note that a UE can have more than one IP address from several PDN gateways.